All right. Hi. Welcome to the webinar, everybody. Thanks for being here today. We're going to be talking about delivering secure cloud infrastructure at scale with AI. With me here today, we've got Tarak. Tarak is one of our co-founders. He is going to be in the chat, interacting with you guys, answering questions that you might have. So he's going to drop from the stage, but no, he's going to be here the whole time to kind of help out with you guys. I've also got here today Safe. Safe is a principal security engineer at a large technology company, over 5,000 employees and about 4.5 billion in total revenue. So they have a good sense of what it takes to secure technology and build things in the cloud. So we're super excited to have him here today with us. And so Tarak, I'm going to pull you off, and then Safe, I'd love for you to tell us a little bit more about yourself.
Thanks for having me, Justin. Hi, everyone. So I'm Saif Attab. I'm principal security engineer. I have, I would say, deep experience in telecom, security, and telco. I worked in healthcare for some time, and now focusing on DevSecOps and AI. Not because these are one of the top two buzzwords, but yeah, that's where our biggest problems are.
Yeah, healthcare, like not a heavily regulated industry, right?
yeah. I would say a high impact industry in our lives.
That's awesome. So, the whole focus today is on cloud and on security and on AI. And I think AI is the interesting piece of this conversation. We've been talking about cloud and security for a long time. Early days of cloud, there's a whole lot of conversation about what it actually even meant to move your data centers to the cloud, how that could be secure, a lot of hesitancy from business leaders and technology teams about how to adopt that. Now cloud kind of feels like table stakes for a lot of companies, and like how you leverage cloud effectively. AI is sort of this new wrinkle in the way that we're managing security at scale, managing cloud infrastructure at scale. I would say that, what I'm seeing these days, I'm curious what you're seeing in some of the work that you do, but, trust isn't quite right where it's kind of the early days of the cloud. How can I trust it? How do I know it'll do what we need to do? So I think about like the early days of the automotive industry, like cars, you had to crank them up and they broke down all the time, and you could reach in the window and steal stuff out of the passenger seat. So it's early days, but what are you seeing on this front?
Yeah, I think we're gonna need 5 more hours just for this first topic. But yeah, it's like the fundamental challenge is like what we see at most companies, especially companies that have like large cloud footprint or are mostly building on cloud, is mostly related to let's say fundamental challenges around misconfigurations. We all have misconfigurations. They can be default configurations or human mistakes or just bad habits. That's a reality. I mean, if you look at most of the data breaches, and if you even go back, let's say 10 years, in time, and you will see that most of the biggest data breaches, most impactful ones, were caused by, say, simple problems, simple mistakes. We are human at the end of the day. However, those cloud configs, it could be as simple as an open S3 bucket. But then there is also ambition. We are also victims of our own ambition, and we want to ship faster. If we ship faster, I know on one of our previous conversations, we were chatting about velocity. I would say velocity is becoming more volatility. It's like we build faster, we move so fast that, of course, we may break things and learn from that, but we may also cause more problems. So like moving fast, engineering team, they are already overwhelmed. So for sure, they will neglect what we tell them or what we recommend they do. I mean, we understand that if we were to build something ourselves as security engineers, for sure we may miss some of our own requirements. Yeah, but I think I will close this answer by just saying human element is key to whether stop this from becoming more volatile, but also to reduce the risk, because we have been hearing that phishing is, or let's say email is the #1 attack vector, because humans are behind those emails. They are the one reading them, the one clicking on them. That's from I would say a user end of things. But if we talk about infrastructure scaling and engineering, yeah, those same people, same folks are also building and also occupied where we're like scaling up and innovating. So
Yeah.
yeah.
Absolutely. I mean, I've been working with enterprise for over a decade in the cloud across AWS, Google, Azure. We've seen all these changes. I think with AI, you mentioned like velocity, it really is a big point right now. Like we can move super fast, but how do we move super fast and aligned? Like most of these tools today are individual developer focused. And when you're focused on an individual person, whether it's a platform engineer or a software engineer, it really relies very heavily on them and their ability to be a great prompt engineer, to be able to pull the correct context from your organization. Like, what's the right security document that I should be referencing? Or what's the right, coding standard that I should be using, or X, Y, Z? And so AI helping you move really fast, but without having the alignment of the organization, your customer, the mission of the business that you're trying to support, can really just create a lot of friction and create a lot of negative feedback loops that are really, really challenging, I think, with AI. So it's an interesting space that we're in with velocity. Like you see like we usually would take a sprint and it's like, oh, I could do that now in hours. I could do that in a very small window of time, in particular for things that are very well known and that we do consistently. So absolutely seeing that across the board, and like that lack of like the trust at scale of like large teams to be able to deliver with AI in an effective way. That's kind of step two. Adoption number one has been the hard part too, just getting people to trust the tool itself, to use it to do the work or to replace the existing workflow that they have. Misconfiguration is a huge one, right? So we see misconfiguration and customer side mistakes still, even with AI being the number one driver, and maybe even amplified by the fact that we have AI. So there's a widely cited Gartner estimate that says up to 99% of cloud security failures are the customer's fault, like mostly misconfiguration and poor controls, right? So that matters because even with good cloud security, posture, identity drift inside of your tenant, still the main failure mode of what's there. So how do we use AI to kind of constrain and control those types of things while we're getting the benefits of that kind of velocity and scale and helping people to ship more things faster, but with really, really high security? What are you seeing around like security defaults and things like that? People are building in the cloud. These incidents exist. We see still today 80% of organizations roughly are multi-cloud. So what do you see in terms of good ways to get reliability and security out of AI and embedding that into workflows, whether it's a security engineer, as a platform engineer? And can you talk a little bit about toxic combinations? Because I know we've talked in the past a bit about toxic combinations, and I love the way that you present some of this information around cloud incidents and AI.
I would say, let me start with my favorite toxic combinations. We talk about misconfigurations. They can be by default bad habits or just mistakes. And if we talk about vulnerabilities and risks and misconfigurations, I would say what's more impactful, and I would say at least the scariest part for me, is when you have these toxic combinations. Imagine you have a vulnerability, whether it's, let's say, 10 out of 10 vulnerability, and it's on an internal asset, with only accessible like from the inside of your company versus something exposed to internet. So which one has the highest likelihood of being exploited and used against you? Of course, the one with the highest likelihood is the one that's more exposed to the internet. And then you have what attack vector, like if we have a house and we are only worried about somebody getting in from by using one of the entrances or by using the door and forgetting about the windows we always leave open, I mean, it won't make sense. It's like same concept when you talk about misconfigurations and vulnerabilities. If we have to focus on the most important ones, we have to look into likelihood and impact in a way that's adapted to our context. Are the assets that we have exposed to internet supposed to be exposed in the first place? Versus like, if this end up being exploited by someone with bad intention, how bad it can be? Like what's the impact? Like it seems so simple, but it is simple. It's like if you look at it from like these basic principles, and these are fundamentals. We cannot boil the ocean, we cannot fix everything. That's why toxic combinations, look into likelihood, look into impact and start from there. And then, of course, you can rely on other elements related to whether industry standards or scoring systems, because the more you adapt them to your context, the more effective you're going to be in reducing risk. Yeah, toxic combinations. I talk about hybrid cloud. Hybrid cloud introduces complexity, and if a company is like say 80% using one of the top like three CSPs, and they have to start using another one, maybe through mergers, acquisitions, or maybe because they have to be compliant with some new regulations, they have new business in like a new country or region, and they fall into the compliance trap. It's like, okay, we got to be compliant with these regulations. We need to have data residency, and we have to use this vendor, this CSP, because that's our only option. So usually, like we get there, we get into that complexity because we want to make more money, we want to scale up, and we want to stay compliant.
Yeah. Yeah, and at the same time, safe, right? So why does all that matter? Because you think about more clouds, more environments, that's more identities, that's more configs, that's more attack paths that you have to securely and consistently kind of go back to and know how to monitor. And so it does create not only this like complexity of cloud problem, but also a complexity of like experience problem, right? Identity and skill gaps are still big choking points for a lot of organizations. I think roughly 70% of orgs report a shortage of cloud security expertise, right? Cloud security has always been in demand. And like, I only see that increasing with AI and getting more challenging. Do you see that also as being one of these challenges where, of course, like misconfig due to the complexity and the nature of cloud and the way that it's changing so rapidly? But also, where do you see like the human element of this and the skill set element of this and like how we make everybody great? And then also as a component of human element is like the AI part. Like, so where do we start thinking about bringing AI into these human workflows, these things that we do today to actually improve security? Like, what are some good low-hanging fruits around that? So yeah, just thinking about the people, the skill gaps, and then the way that we leverage AI to kind of level the playing field and improve the way that we deliver security in the cloud.
Yeah, great. I would say great. You know, when you started your follow-up, I was thinking, yeah, skill gap, and then you mentioned it's like, okay, we are on the same page, because it's human again. It's like if we are working on AWS, we are familiar with it, and then we shift to another CSP. So for sure there will be a skill gap, or at least like I know at the end of the day, it's like the fundamentals are the same. I think this is the fifth time I use this word, but again, yeah, if you miss the fundamentals, you will have bigger problems with time. But yeah, the skill gap will increase when you have a hybrid cloud. But if you go back to the basis, you shift toward more to infrastructure as code. You have like templates, you templatize the work and the best practices. You have less risk of like errors and mistakes and coming from whatever behaviors, habits, or just the culture. If it's like a merger or an acquisition, that can also be the case. But yeah, you mentioned AI. If we look into AI as a solution, I know in the beginning we talk about velocity. I mentioned volatility because velocity can bring that as well. It's like it will exponentially, like if you move faster, like with bad habits, you will have like exponentially more problems. The same thing if you introduce AI without having those, I would say, guardrails and context, you will cause the same problem. I would say even at larger scale. So how can we, first, if you adopt AI, and it's like if you hire someone and they don't do onboarding and you expect them to do things correctly, it's like, that's insane. I would never do that. Why would you use AI like out of the box and expect it to act the same way you do?
Exactly. And when we typically interact with an LLM, like if you're using ChatGPT or something like that, there's like this concept of memory and it can curate information about you over time. but there's all this non-static information within the organization that's like constantly changing, security baseline strategies, all types of different things. And so to expect every individual person to be up to date on everything security is doing every day as a full-time job, but to be able to implement that into like their daily workflow at a totally different kind of like velocity and layer, right, is kind of, it's difficult, like let alone like that you task them to do something without telling them anything about their job or like what they're supposed to do. But even people that know what they're doing, what their job is to do, sometimes we just don't even realize how many blind spots we have, or that the motion of some information is shifting in a way that's different than what I knew before. And so like to get it right is really, really hard. And which is why we have so many defense in depth in most cases, in most companies. It's like there's a ton of bureaucracy and reviews and CI checks and scans that run and all these things that we do to try to drive greater trust. At the end of the day, we still end up misconfiguring things, but we do our best to like bring that together. But so the point of all of that is like you have vanilla AI isn't going to solve all your security problems, because all of your security posture isn't based on some vanilla definition of what security actually means. It's highly contextually based on the system that you're building, the company and the regulations that you're operating under, the customer that you served in some cases, for example. And so, yeah, being able to bring that contextual layer to AI is really important. Kind of back to, I know we didn't really talk about this before, but I'm curious, like, are you seeing any low-hanging fruit for AI and security? Like, I see some things where, for example, for me, if I'm looking at security logs, there's a lot of stuff in the security logs. And one thing that AI is really good is picking like needles out of the haystack. And so like being able to help you not miss something. So maybe you're not delegating responsibility, but you're adding additional opportunities to catch information that you might have missed as a person. I think that's one great way. Like I've seen AI used in like Splunk logs and things like that to try to pull together information that otherwise might be difficult. And if you're thinking about an outage or something, and you've got this window of time you're trying to close, if you can do that discovery in like 10x less time, that's just that much faster you can get to what the actual problem is and then implement the solution so you can bring your systems back online or prevent something like a DDoS attack that's currently going on against your environment or something like this. So is there any way that you're seeing in a practical sense, like security engineers starting to leverage AI? And that could be as mundane as documentation, like making it easy to do research and documentation, or as advanced as building systems to do something, within the environment to be able to catch security vulnerabilities at scale.
Yeah, this is something that fascinates me because that's, I think, the opportunity. Like if you look at AI in the cybersecurity space, like one of the top opportunities for us to enhance our day-to-day is to, I would say, overcome the complexity of dealing with large volume of logs and data. Because we have logs on one hand, we have data on the other hand. When I say logs, I mean, you can be familiar with the logs and the technology, and you can understand it. And you can do your magic with your expertise working with traditional SIEM solutions. You may already have like all the rules in place. You have a great detection engineering team that stay on top of things. But there are cases where you will have blind spots for sure. So AI can be really and is really effective in analyzing large volume of data. That's one of the best things it does, and one of the main use cases that we as security engineers we can take advantage of. Whether understanding the logs, doing the correlation, and of course saving a lot of time, automate anything that's boring for us in order to focus on like more important tasks and the top risks. And then if we go back to the other side of the equation, if we look at the data and look at the security tools, because we are at a stage where the problem is no longer like are we able to detect? Most companies, they have all the tooling they need to have. We have a really good and caring community, innovative community. We have enough open source products to cover every area of risk, every attack vector. So even if you have $0 to spend on security tools, you can still have like an acceptable level of security. So now the problem is not are we able to detect, but now that we are able to detect everything we were wishing we could have get access to, what are we doing with all this data? What should we fix first? How do we prioritize it? How do we make it align with like other frameworks. And it's like companies usually they have a really solid way of managing risk as a business. How can we translate that into how we prioritize risk as a security team? That's where AI can help us. We deal with the other part. We talk about logs, we talk about data. If you have security tools doing scans across your CI/CD, and you have findings coming from SAST and Pentest and Bug Bounty and the CA, and then you have a CSPM and secret scanning, it's like you have the whole suite, you have all the signals you need, but how can you prioritize that? And
Yeah,
the tooling,
that's such a good point, because I would say I would actually, I don't want to revise what you said, but you said you have all the signals you need. And what I would say, I would argue that what you have is like all the noise that you can handle. Because like what it actually ends up feeling like a lot of times is I've got 10,000, 20,000 security vulnerability alerts, every single package in the in the code base, every stack, applications, data, infrastructure. And it's like, yeah, but only a certain subset of these actually dramatically could improve, or by resolving them would improve your actual risk posture and your security remediation effort. And so like, yeah, I think I love that idea. Like the idea of using AI to kind of mine through all this noise to get a signal that helps you to actually convert every finding into a very small list of very targeted findings that helps you to go and like solve the impactful problems for your organization. That's really cool. And then last small question on this, it doesn't have to be a big answer, but I'm curious about remediate. Like, what are you seeing in terms of trust around using AI to do the remediation of security vulnerabilities, right? So of course we've talked about detection and synthesis of information and bringing that thing together. I think the absolute great use cases for AI with security. And then what about actually fixing things? Have you seen any of this going on?
Yeah, that's I'd say the tricky part of, because if we are in an environment where we do things right, we have all the tooling, we have all the data, and we are already leveraging AI. We go from make our lives easier understanding the logs, having the right alerts popping up, and avoiding alert fatigue for our like threat detection and response teams. And then we go to the engineering side and the operations side, and we add our context. We let's say we use, for example, whether a mixture of experts or agents, and then like we train them on like our contacts and look at all the data to only have whatever the top 10 things we should be fixing and reporting on. Even like querying the data, it's like we don't need everybody to become SQL experts. We can have an agent that translates their questions into SQL, and they can get the
sure.
data
Drop
they
the
need.
production database. Why not? That'll solve the problem. All your issues go away. Just drop the database.
Yeah, it's like this is like a maybe utopia I'm describing here, but yeah, but it's attainable. So let's say you are already in stage, and then for sure you start like dealing with the temptation to, what if it can go all the way and fix those problems, not just report on them? Because you can have a transition phase where, since now AI understands your context and your risks because it sees the data, it can easily write down the recommendations. It's like, hey, this is the config to stop this kind of issues. And the config, it will, let's say, if it pushes a PR or adds a comment, that will be similar to what you have added if you were looking at that same data and that same risk. So this is one step forward, going from like I reported to now the remediation piece and validation. So you can get there where you can add comments. It's like you suggest to engineers how they may fix. Of course, if you already have the context added, otherwise engineers will complain about it and will stop listening to you and your AI-powered security solutions or agents, whatever you're gonna go with. And so in that case, same thing, we had EDRs doing auto fixes. Like they can isolate a machine because they have certainty that it's infected, or the behavior the EDR is seeing, like, let's say 90% chance that it's actually malicious. It happens. There are some false positives, maybe in some cases. With time, we started trusting that more. So in this case, even CSPMs, they can offer like auto remediation, whether to suggest a patch, push a PR, or like give you the config you need to change. They give you like the 120 lines of code you have to change to reduce the exposure or the toxic combination it was able to detect. So, but you can always start small. You can start with what's non-negotiable. Let's say I do not have any legitimate reason to expose an S3 bucket. Like, just my business is like that. We don't have any use case for it. So if I find anything exposed, I can auto fix it because it's normal, and I have the right to do that. Nobody will complain.
Yeah, you're right. I mean, I think the trust in the AI to take the action is all about where it takes the action, what the action is, and what the level of control is that you're able to exert over the agent to give yourself the confidence that it could do what you want it to do and not do much more than you would actually want it to do. Security and these are all about reducing the blast radius. Like how do we make sure that, okay, if something went wrong, what is the actual surface area that it's going to touch when things go wrong, right? And so there's multiple levels of that, like traditional cloud stuff, like policy. I can block S3 buckets from being deployed at all. So if I start from like first principles, like forget that anybody could ever write the code to deploy it. If they could never deploy it in the first place based on the cloud itself, that's one mitigating control over agents, even if you think about it, right? That you could allow them to do some things that maybe I know that if they were to try something that would not be possible in my environment. Another one is like literally constraining the agent itself, like what actions it can take as it's going through the iterative loop and using the LLMs to like solve the problems and deciding to use tools to take action. Like what are the tools it actually has access to? What are the permissions behind those tools, managing and monitoring those well, and then being able to allow it to take only the number of actions it needs to take to solve the scope of the domain of the problem that you're trying to solve. So I love that. And then there's, I guess one more thing before we talk a little bit, maybe get practical, and we'll do a little bit of a demo of some technology that does some of this, but there's the other side of the problem, which is the security, that there's new security things that never existed before language models, right? Like there's a whole bunch of new stuff, the prompt injections, the issues with authorization for model context protocol servers to do tools, right? To connect the data, to do data, things like that. Like, I'm curious about your thoughts on some of that too, from the AI, new kinds of issues that AI is proposing to us, and then what you're seeing from the security side about how we're tackling some of those issues.
Yeah, that's one more interesting, I would say, time we are going through. Like we were fascinated with this, I would say newish technology, because the real exposure like goes back to back 3 years in time, and everybody getting familiar with ChatGPT, and then like more and more experiments we started seeing like in the community. And AI was already there in most of the security tools, but of course at a different scale and a lot of machine learning. But now that if we look at it, like the main foundation we always forget about, whether we use it for any other use case or we use it in security, is it's probabilistic. It's not like a code you wrote and that will have the outcome you desire for the code. So it's not a software like any other software. This is a technology that's like, there is math in the background, and it's probabilistic. So you can ask same question 200 times, you may have different answers. Like it varies. I would say 100% different. But if you use this probabilistic technology, let's say you have an LLM and you want to build, let's say, a thread modeling assistant. We talked about it in the past, and imagine I upload my new project documentation, blueprint, diagrams, and I get a pretty good Stride, aligned with Stride thread model. It looks good. It saves me hours of work. This is fantastic. Try do next month. Is it the same outcome, or are you seeing different risks? Then you start getting, I would say, overwhelmed. It's like you're gonna have unexpected results every time. I'm not saying those results are not valid or false positives. That's a different story. But if you have this uncertainty of outcome, would you trust that tool? And you spend a lot of time, of course, making it better and enhancing it. That's why we talk about, like, and we hear about that a lot, like context engineering. And I'm sure you hear us talk a lot about context in the next 30 minutes for sure. But yeah, but if we start from there, we understand this, and we understand that it processes text. I'm still talking about LLMs. So it it's like it's like the same way we can social engineer human. Like when we do prompt injection, we are kind of social engineering LLMs, and whatever we feed them, they will process it. Whether they're gonna be like we're gonna bypass their guardrails or not, but it's like there are no filters. We give it text, it's happy to look at it, to process it, and to give us an output. That's what it was created for. So that is this thing we need to, like, if let's say go back to the foundations, we need to remember that it's probabilistic. And then this same technology we built on top of it, we are in a, I would say, in a great time where we have like again large community, and big tech is also heavily contributing to this. We're getting to a stage where we can have autonomous AI. So when we get into like agents and MCPs to add context, we start using RAG. This is great. So it solves a lot of the problems we have seen, like in like I would say maybe 2 years from now. However, now we are giving AI the ability to take action, access tools, and be autonomous. The same way, like like I mentioned earlier, if you hire someone, would you expect them to do the right things without training? Even with training, they may do mistakes. So the same thing, would you give them like privilege access everywhere? Say, no, I will never do that. Like you need to think about like one of the information security foundations and just give them the access they need, and they only see the data they need to access to do their job. So why you won't follow that with AI? So we talk, like if we talk about LLMs, the top risk is like prompt injection. If we talk about autonomous AI and we talk about agents, excessive agency will surface as the top risk. And so these are problems we have known in the past. When I talk about autonomous AI and talk about like privileges and what AI can do and its ability to take decisions and access tools and do something it wasn't supposed to do, or somebody taking advantage of that, those permissions, that's similar to like a service account that can do disasters or cause disasters, or somebody with more permissions
I
than
think
they need.
the trick that I think that a lot of people struggle with is this balance between the autonomy of an agent and like constraining its actions or being confident that its actions aren't going to go too far or do too much, more than it should be able to do. Because one of the key features of an agent is agency. Like I can solve a problem in a pattern that may be slightly unpredictable, but get you to the right answer. When I think about like traditional software, you've got like a current state and then you've got like a target state. But that target state is driven by deterministic UI clicks, and every path to that target state is pre-rehearsed in the software. It's written for you. It's a path that you can follow. And when you try to go down a path that doesn't exist, the application throws you into an error boundary. Like there was nobody that programmed for that scenario. So I'm going to give you some error issue, or I'm going to give you some generic routing to some other page or something like that. Like, so you're very constrained by that. But with agents, you have this amazing ability of saying there's a desired state and a target state, and there's actually a million paths to get to that desired state. Like if I want a coffee and I have an agent that has like an MCP server or something with Starbucks APIs, I can ask it and it can figure out like, oh, you didn't give me a credit card number. You didn't tell me your name or like what location you wanted to buy it from. And so it's this cool thing. Like I didn't have to program for that fact. It looks at contract and then it tells me this is the information I need to do the job that you're asking me to do. So I think it's really interesting. Like the idea is like, let's not think about how do we make AI so deterministic that it becomes an AI workflow. It's so predictable that, yeah, it's always the same outcome. And maybe sometimes AI workflow is the right answer, but where you need true ability for an AI to search a space and to solve a more complex, nuanced issue, really comes down to control and access. Like, how do we control the agent? How do we give it access to only what it needs, reduce the blast radius, and gain trust over what it can do? So it's super interesting to think about. There's a million things we could talk about: agent identity, MCP security, so many different things that have come up as security concerns. But again, going back to the car, we're at very early days of building this AI automotive, right? And so we're trying to put better doors on and make it so you can lock the windows and all of these types of things. And so it's an exciting time to be working with AI, I think. And like, my encouragement to everybody in the security space, or like whatever job you may have when it comes to AI, is like, just within the confines of like your corporate policy and what's allowed, and using the tools that you have available to you, like, just experiment with it and don't be afraid of it, and like, think about how it can make you more superhuman. Like, what are the areas that it actually makes sense to use for you, and where it doesn't, it makes sense to use. I think it won't be long. Like, we're going to be thinking about AI like Excel. Like, it's just another tool that we all use every day, and it's embedded into the way that we work, and it's just going to be great for us. So, well, look, I think, Saif, is there anything else that you wanted to talk about from a security perspective before maybe we try to bring some of these concepts to life and talk about platforms, solving some of these problems?
Yeah, I think before we switch into demo or talk more about platform, like if I had to summarize, we talk about whether we talk about scaling, velocity, and the most common problems, and then AI coming into the mix as a solution, or also as an amplifier of the problems we already have. And I use the analogy of, if you hire someone, would you have them go through boot camp before they touch production, or they start doing their thing on day one? Like, remember that AI is as good as how, as much as, I'd say, as much as context you give it, that's as good as it can get. So expect it to be like reliable, and to understand what you want to build and be supportive. And I feel that I'm talking about a person now. When you said supportive. Yeah, but it's like,
First to feel that way, right? A little bit,
yeah. Yeah. So yeah, maybe, yeah, it's like, as much context as you give it, as good that as much context you give it, that's as much benefit you're gonna get. So it won't do the right thing unless you tell it to do the right thing by adding your context. So if you wanna write code with AI or build infra with AI, and you add your context and best practices and what's normal, it's like I mentioned earlier, an S3 bucket, it's open. Yeah, what product is it, that's part of? Is it normal or not? And then first you will have less false positives, but again, you will build securely from day one if you teach AI how to build securely from day one. So yeah.
Awesome. Well, hey, look, just a little bit of, like, for everybody, transparent. Thank you very much, Saif. This has been an awesome first half. We're a little bit over, so I'll try to accelerate some of the back half. When we go into this, I would love for you to like add commentary, ask questions, really be more of a discussion than a presentation. But I'm the founder of InfraCodebase. So InfraCodebase is a tool specifically designed for platform engineering teams to be able to deliver infrastructure as code at scale in a way that you can trust, so that you can actually ship it to production. We don't want to trade time off for speed, for quality, speed for security, or speed for more governance and review time from teams. Because if we're getting speed at the cost of all this other turmoil that's going to go on around AI, then we're not going to get a whole lot of lift and benefit out of it. People are going to complain they're spending as much time reviewing code as they were just writing it themselves. And so why in the world would I use AI to solve some of these problems? So context is exactly right. Like you mentioned, is something that we really have to think about. And let me make sure I can get the right slide up here on the stage. Is like, not just context, because context is absolutely yes. Like, what is the context that we're operating, the agent's operating within? But also, how do we make it so that you can federate in really large teams, in large geopolitical environments, without worrying about the quality reducing based on the person's skill level, the integration with your team, whether they're an employee or a contractor, they've been at your company for 1 day or for 10 years, right? How do you try to create a system that lets you build in a way that gives you those consistent levels of results? So InfraCodebase, this is a very broad view of platform, what it is. There's an interaction layer. So as a user, you're working with primarily our UI. We're also introducing a terminal as well. So you can bring your agents and all of your rules, tools, workflows, guardrails into your local IDE environment as well. So developers that are used to working at their computer in front of VS Code instead of working in a third-party product can do that, right? So that's the interaction layer. And then you've got the agent governance. When it comes to the product, and we'll see this, there's an agent API, of course, APIs for all the other things that we do, but there's an enterprise. The enterprise is like your billing and it's your integrations, but it's also like the MCP tools that you connect to. So on the agent context layer, the MCP tools that you connect to, the rules and requirements that you want to enforce, the workflows that you want the agent to be able to follow whenever it's doing IAC development, and the different agents that you may want to build into the product to be able to solve individual security issues or general issues. You might build a security engineer agent. You might build a platform engineering agent or a quality review agent. It doesn't have to be cut across the lines of a person or a role. It could be different vertical or horizontal slices around how you want to run it. So pretty flexible system in how you set it up. But the most important point is like, it's an AI native product, meaning that everything at the center of this thing is the agent that is like pulling on all of this context and being able to execute against things. And the value of that is that now, regardless of where you sit or which team you're on, you can ask more implicit questions, but the agent still has all of the organizational context, so that you don't have to be as explicit in every single prompt that you do. You don't have to be the subject matter expert on security to make sure you do it right for your company, right? Which is really important. And then, yeah, the integration layer, of course, you see like common things like connecting to my issues, like pulling an issue and getting the what's in it, being able to use the modules that I've built within our company to be able to construct whatever I need to do, because we've securely configured all these different cloud services and their own reusable components that I want to use as a part of a producer consumer model. Or I want to be able to reach out to the cloud and get the misconfigurations from our existing infrastructure to be able to make fixes to what we have so that we can improve it and then ship security enhancements based on what the cloud security recommendations are. So you talked about CSPM Safe, and you talked about all these other tools. And it's like, there are a lot of tools, right? Almost every role within the organization has probably like 3 to 10 tools that they're using that maybe has very little overlap with other people. So how do you make it so that everybody can work in one place, have a similar contextual layer without having to change the way that people work around the perimeter? So keep doing what you do today, but give the agent the ability to understand what it is so that when it builds, it's aligned to what you have. I don't know. Any thoughts on this? Maybe questions that you see or you can anticipate somebody having when you review, see something like this?
Yeah, I think when you look at this like scenario where you are leveraging AI-powered platform in order to, let's say, ship faster or manage your, let's say, infrastructure at scale, and you integrate it with all your tools, and it seems like an organic way to enhance your operations or even focus on some, I would say, systemic issues, whether it's related to security or reliability. And it's like you can think of having the ability to either cause more problems at scale or quantify them and fix them gradually. And yeah, it's like you can, when I look at it, thing I got in mind, I think the first time I looked at it was, first, like access to the tools. How are you going to manage those identities and permissions? That's the first thing I saw as a risk, of course, because it was new to me. And the other one is, how can I add my best practices? Like templates, or it's like, how can I templatize my best practices, non-negotiables, and embed them into this platform? Then regardless of who is working on it, who is building, at what stage, at what environment, I can have like a peace of mind knowing that they're going to do the right thing because I'm expecting them to use the templates. So
yeah, so let's dive into a little bit, and I want to make sure we're 15 minutes out, so I want to make sure we have time to go through. So I'll probably talk for a minute. Maybe I'll just start here, and I won't go too much into all of this configuration, but basically you have workflows in this product. Workflows are like a way for you to build out a common flow that you want for your agent to use. So this is a semantic router for agents to be able to say like, okay, before you start writing code, maybe like help me create a technical architecture plan or come up with a security posture point of view, right? Like understand what like XYZ. Rule sets are the way that you can publish enterprise rules and leverage those into workspaces when you federate. So these are all just a bunch of different types of rules. These can be specific to specific types of resources within a specific cloud provider. They can be framework based. They can be language based. So in this case, like right now, we have our Terraform configuration language style guide as a non-negotiable for all of our workspaces. So whenever we write code, the Terraform rules get applied. So you can see here, here's all the different rules that we have to be able to manage infrastructure as code. And again, you have these for all these different kind of domains or things that you may want to use. You can also create rule sets. And the nice thing about creating rule sets, you don't have to do it from scratch like this. You can take whatever documents you already have to your company's security requirements, baselines, et cetera, extract the rules. This is right now I'm using like a public URL. So this is actually leveraging Azure Secure Baseline for PostgreSQL. I'm adding in a brand new set of rules to the platform so that when we work with Postgres, that if people know that they're using Postgres as a part of their architecture, they can turn this on, and then they're able to take advantage of whatever Microsoft says are the best practices for that stuff, like network security, like having network segmentation boundaries, cloud services with network security controls, disabling public network access, things like that. So this will go through and pull out all of these different rules, right? Deploy service into a virtual network, configure network security groups, disable public network access. These are just generally best practices and like how to implement them. So I can import this rule set, and then this shows up now in an inventory of things that I can publish to the entire enterprise that gets used inside of a workspace. Then you've got tools. Tools are MCP servers. So you can connect whatever tools that you have within your ecosystem directly to this. Secrets are encrypted and transited at rest using military-grade encryption so that those secrets are safely stored and secured whenever you're connecting to these services. Another thing we have to think about is exfiltration of those secrets within the chat experience as well, because the agent clearly has access to use those to connect and do different things. And so how do we mask and obfuscate and remove those types of things from the chat experience? And then you have sub agents. Again, you don't have to go through this, but like you can create different types of agents if you want to use those to delegate to within your flow of work within your workspace. A workspace is, I would look at it equivalent to like a GitHub repository. So whenever you're doing an infrastructure as code project in a typical environment, it might be a reusable module or an application landing zone, or it might be an entire landing zone for some shared component, core networking and things like that. We're going to create a new one here. And in this case, I'm actually going to connect to an existing set of code that we have set up for this demo in particular. We can pick your repository. So this is based on a GitHub integration that you set up within the product. And then you can connect this directly to things that you already have. So in this case, this is going to be private because the visibility from GitHub is private. So this is going to stay private on my side as well. And then from here, this is the experience that the typical person on your team is going to have. They're going to have this more like lovable style experience where they can see all of the code over here on the right-hand side, and they're going to have a chat experience over here on the left. The first thing I may want to do in a case like this is like, can you create an architecture diagram? Oh, let me just do it this way. Can you create an architecture diagram of what we have so that I can see what's there? So the first thing I may want to do is like do a little bit of discovery. It might be day one for me, or who knows, I could be on a consulting team, or I might just be new to a company or whatever. And so it can actually go through and take a look at all of the different things that we have. Right now, it's actually delegated to a sub agent, which is an explore agent that's able to go through and do rapid exploration of all the different things that we have to support the main agent and being able to do what it needs to do. The other thing I'm going to ask it to do here is say, can you connect to Azure using the CLI and give me the security vulnerabilities reported by Azure for these resources. Okay, so we'll let this do its thing for just a second. I'm gonna actually I'll just add one more thing here. Can you add those to a markdown file? So I'm gonna queue that up. So that should in a second whenever this is done doing what it's doing, it will let us do it. If you look at this architecture diagram though, so I can actually take a look now at what's here. So we have like an app service plan, which is connected to a web app. And that web app is monitored by Application Insights. It has a managed identity that allows it to access the Key Vault. There's a shared Key Vault and there's an application Key Vault. I can also see there's a storage account here that's connected inside of that same resource group. There's a public container and a workspaces container. And I have a PostgreSQL database where secrets are stored. So the PostgreSQL database secret is stored in the Key Vault, and it's also queried by the web app, right? So the nice thing about this is there's a quick way to like kind of discover like whatever your infrastructure is as it is. And so if we go back over here, we can see now that what this is actually doing is it's authenticating to the cloud, and it's going through and figuring out what are all the security opportunities that are being reported out of Azure from Defender and directly from the resources themselves. So it's going through and it's doing its own discovery of our real cloud environment that this code is actually connected to, and able to see what our provider is telling us should be fixed. So I'll pause there while this is running safe and see if you have any questions.
Yeah, I have thousands of questions. This is really interesting because, especially when like you can build, you can review your existing infrastructure, and then you can also enhance it. And when looking at how good are the agents into like building architectures, whether it's like showing you the diagram or then like giving you all the code you need to deploy it, and at the same time following the best practices. I was thinking this would be really good at threat modeling. That's
Yeah.
what my brain went. So is this something you tried or?
Yeah, so we could ask it like, can you create a threat model for the current architecture that we can review? So the architecture mode is a beta mode, but it's really intended not to replace cloud architecture. Actually, cloud architecture is an input to this, right? So in a normal situation where you're doing like a greenfield thing, you're extending something existing, you might upload your documents from Lucid or from Draw.io or whatever tool that you currently use to inform the agent about what it should do in terms of like changes to the environment. But what it is designed for is to help you to have some discoverability about what's there, right? One of the friction points with AI is what was actually deployed and how do I know what's there? And so this helps you to be able to solve some of those problems by making it obvious, right? So I'm going to go ahead and like ship this thing off to the queue. And then we're going to take a look at the security vulnerability assessment here. So we can actually take a look at this, and it'll give us like an executive summary of everything, the overview of what's actually there, and then all the highest vulnerabilities that it found from Azure and the things that it will need to do to enable fixes to all of these different vulnerabilities. So now we've got a good sense of our current posture as it relates to security, right? And right now it's doing an analysis of the current architecture and data flows to see what the threat actors and vectors might be, and to create a diagram to support the request that you had. So layered on top of this thing here, which is good documentation for myself about what are the actual surfaces that need to be touched or fixed to get my policy from Azure into compliance, would be to say, how do I actually model it out and kind of get a visual of what that could be like. So over here, again, we've got what we had before. And in a second, we'll be able to see what the threat model diagramming piece of this would look like. And it can really create whatever you want, data flows. One of the interesting things about infrastructure and architecture is that there's multiple layers. You might have like an L1, L2. You might have data flows or network diagrams, X, Y, Z. And so this gives you the flexibility to be able to do some of that. So here you can see, like, for example, you might have in the current architecture an external threat actor that attacks from the internet. So the internet is the threat boundary, and it could have do direct DB attacks against our SQL Server database, and then data enumeration as well. So in this public container, right, it could like look and see what's inside of that public container from the public internet. Down here, let's see, we could see. Let's see what else it also had this custom domain. There's HTTP traffic to an app service. And then that thing can like, pull container images, make API calls, do all these types of things if it's exposed to the internet. You can refine this with the agent and work with it to improve the images or the layout or like the way that things look. There's a couple different modes to look at it too if you want to see like what the different actors are, how it's set up. But yeah, so this is the current setup here. And
I like. Sorry to cut you off, Justin. I like that it shows the attack paths, because if you are looking at code, I mean, you can do code review, you can track like all the documentation, you can look at all the diagrams, but it's like if you do threat modeling at the infrastructure as code level, I think that's the deepest you can go. And of course, human may miss like some details, even if they know all the context. So if you take the human context we have and you add it here and you keep enhancing it, and then you take all the flaws or vulnerabilities that like the threat modeling of, let's say, version 1.1 of what we are building had, then you can have rules that say the next version should not have what we highlighted in the threat model, or maybe we can document that as a risk. Yeah, but this is giving me a lot of ideas, and I'm sure this will make a lot of security engineer lives easier, not because they can do it faster, because they can make it self-service at scale engineering and quickly, and it's familiar. So if engineers are already using infra code base, what if they can thread model that? Yeah, I love it.
Yeah, and it even like handily put together a document for us to be able to review in tandem. So this has like a stride threat analysis. So it talks through like the spoofing threats, the tampering threats, like the things that people could do, some of the mitigations that we may want to put into place, repudiation threats, right? So just going through the stride framework and like what are the different things that could be issues for us. And then now what the agent is doing is actually going through and it's creating. Before this was like infrastructure was set up to be public, so we could show this private connectivity piece. So now you could actually say like it's going to create the virtual networks and everything else that are needed to be able to support this as a private thing. So for example, before didn't have this, but we have a virtual network set up. We have a subnet for the app service for the Postgres database and private endpoints for things like the key vaults and storage accounts and stuff like that, as well as a network security group for private endpoints, and then associations between the private endpoint and app service security groups to these things. And so all of this is stuff like now you're actually taking something with public services, you're putting it behind private networks, and you're able to continuously improve the way the infrastructure is set up. And so it's just going through this whole process now of like updating all of the code. And we may or may not run out of time, and I'm going to switch back to our faces a little bit so we can talk for a second. But the final step would be, once this is done, you could see it's linked to this GitHub repository now. So it can create a Git commit, and then you can raise a pull request here to be able to push all of this directly to GitHub. Now, right now it's saying there's no differences between the main branch and the main branch because we haven't asked the agent to create our feature branch to put all this code into it yet. But once it does, then we can actually raise a pull request against what we have in GitHub and see the full diff of what the agent did and what we have, and then do our human review of that and continuously give feedback and have it push more things to that pull request so that we can improve it. So I'll let this keep running. I am going to emphasize us a bit in the stream though, here with the last couple of minutes so we can go through. But yeah, I mean, I think what that really demonstrates to you is that you have an agent, it has enterprise guardrails, rules, and guidelines. It's able to pull from your existing repositories. It's able to connect to your existing cloud. It's able to do security discovery, essentially documentation, and then help you to not only do that, but do what a lot of the modern CSPMs are doing and things, which is to modify the source of truth for organizations that are doing things in a cloud modern way, which is IAC. But rather than that, you could use the tool directly. And if you need to integrate with one of these tools, the security tools, you treat it like a provider. You create an MCP server for it, you connect to it, and then you leverage its capabilities into the agent to be able to do a lot of the work that you might do upstream and like your CI pipeline and things like that.
Yeah, I think this is really empowering. At the same time, I'd say it works well for an AI. I'm just kidding. Like when an agent does threat modeling, like the first try, and it looks good and it makes sense, and it shows like the paths you may have discovered or identified yourself. Yeah, I think I feel good about that.
Yeah, I think that it's to build a system like that is not trivial, right? There's a lot of security considerations between the
Yeah.
agents and the servers, and then all the different actions that the agents can take. And so, being able to drive that control in a way that you don't have to write the software to control it, but you can actually toggle those things directly in a UI for users, and you can make it uniform across your team is really important to be able to have like that confidence for federation and at scale to be able to deliver aligned infrastructure that actually moves the needle forward to help shrink the time that it takes to go from like a business request to a new application or something sitting on top of or running on top of the cloud, data pipelines or whatever it might be that you're trying to produce. So Saif, I just want to say thank you. I know we're at 1:00. I really appreciate your time. Thanks for bringing your cloud security expertise to the conversation. Always interesting to hear from experts in the field on what they're doing with AI and thinking about in terms of security. And thanks for humoring us as well and talking through our product and showing you a little bit about how we're thinking about how you can leverage agents to secure infrastructure in a way that scales for the enterprise. So it's been a lot of fun chatting with you. And maybe last 30 seconds, where do you see AI going next? Just whatever time horizon you feel like predicting on.
Yeah, yeah. So I'm not a wizard. I don't know the future, but what I'm certain of is we need to get first. No, besides the macroeconomics around AI, energy, data center space, and of course that's a reality, and chips and supply chain, and impact of supply chain risk on technology, on everything. We have seen that during the pandemic. Like all supply chains were impacted. So I'm not gonna go that route. I'm not an expert in that space, but what I'm expecting is, and what I think we have control over is us using it better. That's what we have control over. I'm sure it will get better and cheaper. And I know we had a great question in the chat about it. It's like PhD level question about securing like zero trust and like building at scale and like managing access to GPUs. And I know that's like maybe somebody from OpenAI was asking that, but it's that's the truth. It's like those large scale problems are a reality, whether on us as somebody, let's say, using AI or building with AI or fine tuning, like building at maybe smaller scale that what big tech is building. But it's a reality. And if I have to summarize it, it's like we need to get better at using it. We should not trust it by default. The zero trust we have been hearing about, not as a buzzword, but as a reality. Like we don't trust. We always verify. Same thing with AI, and we don't trust it. We always verify, and we don't give it access to our like kingdom and expect it to not make mistakes. Human make mistakes. AI will make mistakes, maybe at a larger scale. So yeah, we need to learn how to use it in a term like where we give it the context, don't expect it to do the right things just like by itself. Even if it does the right thing, it might be generic, not adapted to our context. For example, you were using Azure best practices, security best practices, but in like if we adapt that to every, let's say, customer using the platform, they will take that best practice from Microsoft and they will adapt it to their context, because it, like with the CII benchmarks, it doesn't make sense to just follow it 100% because we all have different environments and goals. And so yeah, short story.
That was a big 30 seconds, but I like it. I like when I order a small plate and I get like a really big dish. This is why I go to Mexican
and you don't know what to do with this.
Yeah, you get so much food. Yeah, so I think, look, absolutely right. I'm going to wrap it up by saying I think that foundation layer is being built today by a lot of different companies, a lot of different people. It's going to be critical to trusting AI at scale, especially as AI becomes increasingly important in our day-to-day lives and increasingly subtle in the way that it actually integrates with our lives, because I think we'll actually notice it less, but it will be doing way more with us, for us, and all these types of things. So Saif, thank you again. Really appreciate the time. It's been awesome. This is I couldn't have asked for a better Christmas present or a better conversation from a smarter guy.
Thanks for having me.
Thank you for the time. Thank you, everybody that joined. Take care. Merry Christmas. Happy New Year.